Here we are ready for the Unit 7 test to review. We have drawing a polygon UV, W, X, Y, Z in the coordinate plane, given the vertices U being -3, -3, V 1, -3, W is 1, 1, X is 3, 1, Y is 3, 3, and Z is -3, 3. So what we have to remember is an ordered pair is the values of X, Y. Remember our X is this axis right here, so we go left or right first and then up or down because our Y axis is there. So for the first one, for you, I'm going -3, -3. So I'm going to go to the left, 1, 2, 3, and down 1, 2, 3. And I can put my point there. That would be you. Okay. V is at 1, -3, so I'm going to go to the right one because it's a positive one, and down 1, 2, 3 would be V. W is at 1, 1, so I'm going to go over 1 and up 1, and that would be W. X is at 3, 1, so 1, 2, 3 to the right and up 1. Oh, looks like I'm kind of in the way of myself there. I'll move my W here so I'm kind of out of the way. And then this is X. Y is 3, 3, so that means I'm going to go to the right 3, 1, 2, 3, and then up 3, 1, 2, 3. And here would be Y. And then finally, Z is at -3, 3. So -3 meaning to the left 3, and then up 3. So Z would be over here. This is an unusual polygon, but if I connect my points here, here, oh, look at there, okay. It's not a rectangle. It looks like it's got part of a rectangle missing. So we could even find the area of that if we had to, either by counting or something like that. All right, number 2, it says a team of 4 players competed in a horseshoe contest, and the names and scores of the players on the teams are shown on the table. So we have Sam, Pam, Dan, and Stan. And their scores of -5, 4, -3, and 0. If the lowest score wins, lowest score, who wins? Well, I could even use a number line to figure that out and figure out that, okay, if I have 0 here, I've got 1, 2, 3, 4. And I've got -1, -2, -3, -4, and then I'd have -5, another one there. If I go from left to right, I'd have -5, then -3, and then 0, and then 4. So if I put them all in order, so my smallest one would be the one all the way to the left, which is the -5. So Sam is our winner. Winner, winner. All right. Moving on to the next page, or the back side there. Tony graphed point P on the coordinate grid. So we have it right here. He will graph point Q at a location 4 units away from P. List the order pairs that could represent. So here's the thing. Here's P right here. Okay. And if I'm 4 units away, I could go up 1, 2, 3, 4 and be here, right? And so that's 1 point. And if I give the coordinates for that, I'm over 2 to the right, 1, 2, and then up 1. So one possibility is 2, 1. Another possibility, I could go 4 to the right. 1, 2, 3, 4, which would be right here. And where am I at there? Well, I'm at 6, as I went to the right 6, and I went down 1, 2, 3, so -3. Another possibility would be 4 to the left. So 1, 2, 3, 4 right here. Okay. And so that means I'm at this point of -2 and down 3. So -2 to the left and down 3. And I don't want these points on there, so I'll go ahead and get those off. The other option that it could be that we are 4 downward. Let's go ahead and get rid of that. 1, 2, 3. Uh-oh, we're off the grid, but we can imagine that the grid continues right there. And so I'm still over 2, and I'm down at -4, -5, -6. Looks like -7 if I'm off the grid one. So it would be at -7. So those would be the 4 possible places it could be 4 units away. Okay. Number 4, to get a senior discount at a restaurant, an individual must be at least 60 years old. Write an inequality to represent the situation. Graph the inequality on a number line. Well, at least 60 years old. So, like we think about somebody getting a senior discount, they're usually an older person. And so at least 60, they could be like 60 or 61 or 65 or 70. Those are some possibilities that would work. So at least 60, that means this person, X, has to be greater than or equal to, because it says at least 60, so they can be 60, greater than or equal to 60. Okay, and if I'm going to graph that, I have a number line here, and we're just going to focus on the 60, and we're going to add 61 here, and I'll go ahead and put 59 here. And so it includes the value of 60. So I'm going to make a big dot on 60 because it includes that value, and then everything this direction. So I'm going to shade that and make it big there to show that, okay, it's 60 and everything to the right. All right, number 5. Maya will construct a rectangle that has a 5-unit, height of 5 units, and an area up to 45 square units. Write an inequality to represent all the possible lengths of units that the base is B that May could use to construct the rectangle. Well, first thing we need to remember is area of a rectangle. Okay, so if we find that, we take base times height to equal 45. Well, here's the difference though. Well, equals area. Okay. Here's the difference though. This one isn't saying it equals 45. It's saying it's up to 45. That means it can be 45 or less. So really we're saying base times height has to be less than or equal to the 45. And we already know this right here, the height. So it's really base times 5 has to be less than or equal to 45. Now, if I rearrange that, I can change it to a division problem that we could take 45 and divide by 5 because it's something times 5 has to be less than or equal to 45. So if I took 45 and divided it by 5, I'm going to get 9, right? And B has to be less than or equal to 9 for that to be true because 5 times 9 is 45. Well, 8 times 9 is 40. Well, that's less than 45. Well, even 8.5 times 5, that's going to be 42.5. So that works too. So anything less than 9 is going to give us an area of up to 45. So our answer would be this right here. The B is less than or equal to 9. All right, next page. Name an ordered pair that is inside the square but outside the circle. Okay, so we're going to look at this right here. Inside the square but outside the circle. So, inside the square and outside the circle. So that means it's going to be in this spot right there, right? I'm going to erase that. Well, it's not going to come off. Okay, but in that spot right there. So any point that you choose has to be inside this area. So we could choose this one, we could choose this one, I could choose one that was in between someplace. Okay, but any of those has to be inside that square but not in the circle, and as long as it's in there we're fine. So one of my possibilities, that first one that I did was 0, 3. Okay, so one possibility, whoops, wrong way. One possibility could be 0, 3. Again, your answer might be different. Another possibility could be -2, 2. Whoops, -2, 2. And the other possibility that I put in there was -2. Where am I at? Our numbering's off a little bit there. I wonder if it got slid over before we made copies or something happened there. So yeah, okay. So we're at 0, we're at -1, -2. It looks like that would be -1. Okay, so it is a little off there. So I'm going to just erase that one. Let's don't choose one that's in between. Let's just count over. It looks like we're skipping a line. So really, this would be -1/2 and then -1. So -1, +1. So that would be one that we would want instead of this. So -1, +1. Okay, so our numbering's off just a little bit. I think something happened before we copied it. So, but just make sure it's in that and double check your scale to know that you're counting by something. Okay, so name an ordered pair that's inside the circle but outside the square. So inside the circle but outside the square. That means I've got this going on here. Yeah, it's like totally off here. Okay, so really I'm going to ignore the numbers that are on there and I'm going to count myself here. But one of the things that I see, I'm going to just choose, I could be right here, or I could be right here. Okay, so any of those will work. So remember, I'm counting over 2 to be 1. So this would be 1, this would be 2.5. So 2.5 and then up 0 would be one possibility. So 2.5 or 2.5, 0. This one I'm over 3, but I'm down 1, 2. Remember, because I'm counting 2 spaces. So 3, -2 would be another one. Again, be careful as you're counting. Our numbers are off there. And then we need an ordered pair that's inside both of them. So if I take a look, I'm looking for one that's inside both, which is going to be in this area right here. And I'm going to take the obvious one. We're going to say the origin because it's right here. So we could say the number or ordered pair 0, 0. I could say 1, 0. Okay, because I didn't go up any. I could go down 1, -1. Okay, so we just need to make sure we're counting and we have our numbering right. Okay, and about this time, that'd be a good place to put a star. Let's put a star there by that graph. That'd be awesome. Number 6, let's see if I can, or 7, let's see if I can finish this up real quick. To be considered a lap baby and ride in the airplane for free, a child must be under the age of 2. Write an inequality that represents this situation. So under the age of 2, they have to be younger than 2. Can they equal 2? No, because as soon as they hit 2, they have to pay for 1. So we've got x is just less than, because it's not going to equal the 2. And if we did a graph, it didn't say 2, but if we did a graph, we'd have a 2, we'd have a 3, we'd have a 1, and I could then, it'd be an open circle, remember, because it doesn't include that 2, and we're going this direction. Okay? All right, and then finally, let's see if I can be quick. Oh, okay, so Scout needs to earn at least 20 badges to move up to the next level. He's already earned 12, right? The inequality the inequality's there to find the number of in badges. Well, except for it's X, so we're going to say X badges. So how do I change that? Well, I've got to subtract 12 because something plus 12 gives me greater than 20. So if I subtract 12 from that, I have X is greater than or equal to 8, because remember, that's gone. That's how we get rid of it. So I can just rearrange it and have 20 minus 12. So X is greater than or equal to 8. And if I wasn't sure, I could plug them in here, to see which one would give me that answer. 4-point their graph, name them. All right, so I think I'm going to run out of time. So we're going to have to do part 2.